When a Generate Skeleton stage has completed processing, you can preview your skeletal data in the HoloEdit viewport. With the Process Generate Skeleton stage in your selected track, you'll see the skeleton display in bright green. In addition, a transformed gizmo displaying each bone's orientation will be visible at the bone's position. You can scrub through or play back your animation to inspect how well the Generate Skeleton matches the motion of your volumetric clip. Depending on the complexity of the capture, there may be imperfections present in the generated skeleton. The Generate Skeleton stage is especially sensitive to motion, and you may see slight inaccuracies in the result when the actor is making sudden movements. In addition, some baseline jittering and noise will be apparent when the capture is standing still. This skeleton looks pretty good, but there is a bit of noticeable jitter, especially in the shoulders and limbs. We can refine this skeleton and reduce jitter using a stabilized skeleton stage, which smooths the skeleton and can produce a more natural motion. Press the Add Stage button and select Stabilize Skeleton from the drop-down to add a new stage. Right-click next to the Generate Skeleton stage and choose Propagate Intervals. This stage has a single setting, window size. The window size settings determines how many adjacent frames are factored into the smoothing operation on each frame. Higher values can produce very smooth, consistent motion, but can also dampen or delay some motions. Lower settings reduce the amount of stabilization provided, but can be necessary to preserve sudden movement. Like most stages, we can create multiple intervals with different settings as necessary throughout the clip. But since we're working on a fairly static clip, the one interval we created with propagate intervals should serve our purposes. Because there's not any sudden motion in this clip, we'll try an initial setting of 10 to reduce jitter. After configuring the stage, right-click on the stabilization skeleton interval and press Execute. Now that our skeleton is stabilized, we can take another pass to review. Flipping back and forth between the original and stabilized skeleton, we can see a significant reduction in jitter. Because of the high window size setting, some motions have been slightly dampened. This is most evident in the motion of the arms, where the wrist bones trail a little bit towards the bottom of the arm. If extreme precision was necessary here, we could try running a new interval with a reduced window size for this portion of the clip, or exporting the whole skeleton to edit in an external tool, such as with our Maya plugin. Overall, the skeleton looks good enough for our purposes. Let's move on to compressing our clip with SSDR. After skeletonization, we should compress our sequence with SSDR. If we want to add compression, we always need to run SSDR before the skinning stage. This will prepare the final compressed mesh stream, which we'll add skinning to right before export. We can click Add Stage and choose SSDR to create an SSDR stage. SSDR only needs one interval, so right-click next to your stabilized skeleton interval and choose Propagate Intervals to automatically create an interval for SSDR. This clip doesn't have a lot of fine-grained motion, so we'll set Target Bone Count in the SSDR stage to 32, and then right-click on the interval and press Execute. Generating SSDR can take a little more time, so we'll wait for this to process and come back when it's ready to export.